and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Jody Saultz.
Thanks, William. Thanks for joining today's Tech to Tech. This is part 2 of a 4-part series. This is basically talking about how to optimize your printer and things to look for to help optimization. One of the things that's unclear to customers is when they kind of take a break or go to lunch. In most cases, they really don't take care of their printer the way they need to, but it's really important when you leave for 5 or 10 minutes and that paste is sitting on top of your stencil that you need that paste. So you really need to knead the paste. And wipe the stencil, print the board, and observe. In some cases, you're going to have issues just because that paste is not mixed up. It could have separated a little bit due to temperature reasons, or in some cases, it may be getting a little bit thick or hard. So you really need to knead that paste. That bead should be about 1.5 centimeters in diameter, about 5/8 of an inch. And that bead size will absolutely affect the fill pressure that the squeegee is laying that paste down. So does it roll over the surface of the stencil and release cleanly from the squeegee blade? If no, you probably need to replace that with fresh solder paste. Check that temperature and check the inconsistencies that you could have with that paste. Remove the tooling or remove that stencil, check your tooling, inspect the stencil, make sure there's not any physical damage, make sure there's not any hardened paste or excess paste where it shouldn't be, sure there's nothing, debris or anything in those apertures. You could have worn out or dirty fiducials. You'd have rips or tears that you're really not aware of. These are really things you should pay attention to. Cracks or chips in the nano coating. And use a Sharpie style marker to check the surface energy of the coatings. All these are things you should look at when you're removing that stencil for inspection. Damaged, do they have dings in it? Check the angles. And like I said, look to see if there's any dried paste interfering with the PCB seating area under the stencil. And make sure that you check that board to stencil and make sure that you have a good support. I don't like the pin type supports for in most cases. I think the best support for you to get is basically a fixture that ensures that the board gets proper support across the whole thing instead of relying on pin supports underneath. But these are just things that you can check to help optimize your process. Check the alignment and setup. Reinstall that stencil. Watch the process, including the visions. Those vision systems are trying to find those fiducials. So it's important to make sure those fiducials are clean. Confirm alignment and check contact between the stencil and the board. You can push down on that stencil and see if you have any soft spots or low spots. You can tell if you have issues with the board not being supported correctly. And recheck these print parameters, the speeds, the pressures, the snap off delay, speed between speed and distances. Do they all make sense? And you can reference some internal documentation from tech data sheets, like I said earlier in part 1. Get with your paste manufacturer. There is some recommended settings that they do recommend for setup of your printer. And do an overall system check. This takes 5 to 10 minutes. This 5 to 10 minute check can become very costly if you choose not to do these, but it's easy to incorporate. Your skilled operators, your techs that are running the machines, they know how to run them. They know things to look for. So make sure that they take the time just to look at these, during those when they come back from those down times or lunch or in, first thing in the morning. 80% of the time they're going to catch these problems. But if not, there's specific symptoms out there that they're going to be able to find and see and look into those to try to find your issues. Just the right amount of solvents. The interaction between solvent and paper must be adjusted before optimal performance. If you caught part two, we talked about fluid delivery systems. 15 to 20 millimeters wide on the paper when it's wet um, is the maximum you need, 20 millimeters. I see sometimes customers will deliver that fluid to the paper and they have 3 or 4 inches of wetting on there. They're not only wasting paper, but they're wasting a ton of fluid that's being applied to the paper. Remember that 16 millimeters to 20 millimeters. That's really what you're looking for. And the reason for that is that's the only true area underneath the stencil that's actually running across the bottom of the stencil. So why have 3 inches when you can settle for, 3/4 of an inch? Stencil print settings, are they stainless steel? Are they laser cut, non-coated stencils, nano-coated, fixed frame, printer settings, separation speeds, pressures programmed in the solder manufacturer's recommendation. In most cases, 1.49 pounds per square inch is the print force. That's on the front stroke as well as the rear stroke, and then 1.5 seconds an inch on the front and rear stroke for print speed as well. And then on the separation side, zero point 0.1 inches, and the speed is 2 inches per second. So these are just some things to kind of help you get started with, but it's important. If you get too much pressure, your print force, too fast, too slow, all these are going to affect how that paste is basically delivered and how it affects the apertures. Some of the variables, the wipe type, vac dry, wet vac dry. I always say, please, a lot of customers out there are running the dry cycle or the dry wipe last. We've done tons of testing to prove that the vacuum being last, in the case of a wet, dry vac, always seems to um, be able to clean the stencil better than ending in a dry. So just remember that. Try to always end in a vacuum. And then the wipe, every 2 prints, check SPI after every board. If you're getting good results, you can go up 2 more prints, and I would do that till you get to failure. SPI is going to tell the truth on these boards, so don't just say, "Well, my default settings are to wipe or to clean after every 2 prints." Try to optimize that. Use the right engineered chemistry. Um, and I bet you could probably go from 2 prints, and you'll end up anywhere between 8 and 15 prints. That's a huge cost savings, process-wise if you'll follow those, and optimize your printer. And then the wet wipe solvents, there's a water-based solvents out there. Those are usually pre-mixed 15%. And like I said, there's, pure solvents out there as well. Steer away from the alcohol. It's gonna cause you nothing but problems, and you're more than likely never going to be able to get more than 3 prints. And then, match up those pastes, whether it's the lead-free or RMAs, whatever they are, no cleans. Make sure that you get with your chemistry manufacturers, and they can determine whether a 100% solvent or a water-based solvent is the best for your application. These printer defaults, you kind of hear me talk about this in every presentation. They're just default settings, so be willing to spend some time and go in there and change those settings. In most cases, default settings work with some of the solvents out there. When you're talking about indexing speed, they're typically effective. Um, and then further optimization can be seen starting with the vac. The vac usually is set at 1 inch will give you better results than when the vacuum is set at 2 inches. But like I said, these are default settings. These bar type wetting delivery systems, they typically turn 6.7. They're rarely effective for all solvents just because of the way that they saturate the paper. Um, and these solvent bar speeds, these are rotations per second. So um, whatever you do, remember 16 millimeters to 20 millimeters. You may have to slow that bar down. You may have to speed it up depending on what fluid that you're putting through there. And remember, alcohol evaporates a ton faster than engineered chemistry, whether it's solvent-based or a water-based chemistry. So printer solvent settings, default settings on the speed stroke is usually pretty effective for both solvent and water-based. The index speed is typically effective for both water-based and solvent-based. The biggest issue is the bar speed. In most cases, the water-based needs to be about 5 seconds, but like I said, focus on that 16 millimeters versus the solvent-based, where it's usually in 3 inches a second. But like I said, once again, focus on that 16 millimeters minimum width, 16 to 20 millimeters of wetting of that paper. The fluid amount accounts for chemical interaction, absorption with the paper. When you're using a cheaper paper or a more expensive paper, and we'll talk about that in part 4. But in most cases, water-based materials may need to have more rotations than solvents to be effective, and vice versa for the solvents. They may require less just because the absorption rate with these fluids is being delivered to the paper. QFPs and BGAs, most of you have them. QFPs used to say usually show the best bleed out tendencies, and BGAs, those typically where you have most of your transfer issues. So these are just areas that you can focus on. And like I said, further optimization can be achieved by exploring these different wipe sequences. But even on those difficult parts or those difficult pads to clean under the stencil, it's very important to get away from those default settings and always in with a vacuum and make sure you have the right amount of fluid, like I said, on your paper when you go to wiping. Setup tips: make sure those blades are in good position. Make sure they're in a good condition. Make sure they're not bent. I have seen some of those bent before, and the customers, I don't understand why I'm not printing. Everything looks fine, and you can see the actual bend. If that blade is not straight across the top of that stencil, you're going to have issues printing that paste. And then confirm the board support is sufficient. Take your fingers, press down on that board support on top of the stencil. Make sure that you feel that everything seems to be solid. If you feel any low spots or some sagging, or it feels really soft, you probably don't have the board supported in the right areas. So make sure you pay attention to that. And in the wipe recipe, before and after a pause, if, like I said before, if you go to lunch or something, need that paste, come back, do a wet, wet, dry, dry, and a vac, vac, just to make sure that stencil's cleaned up before we go back into production. And check those edge guards where it holds the board, where it clamps the board tight against the rails. Make sure it's good and snug. Make sure that there's not any debris in there. And like I said, ending in his back is highly recommended to optimize your process. So those are just some things to look at. Don't be afraid to change those settings. You'll get a lot better results if you'll just take some time, do some optimization, save yourself some money. So some of the frequently asked questions that we get on this topic is, how do you save money by using more expensive paper? We'll talk about that a little bit more in part 4, but more expensive paper saturates definitely did the different solvents differently. So even using a more expensive solvent and a more expensive paper, you can save money versus an IPA using a cheaper paper, just because of the way that the chemistry is absorbed into the paper. So more expensive paper also is capable of holding some of those paste down in the pocketed areas of that paper a lot better than a smoother, cheaper paper. Our default settings, process parameter recommendations from the manufacturer? Absolutely not. They're just a default number. There's a number that has to go in there. They're meant to change. You can get help from your chemistry suppliers, and you can also refer to paste manufacturer specs. There's some recommendations in those for you to look at. that'll also help you set up your printer. So be sure and look back at those, and it'll help you with your process parameters. So why is board support important? Well, if you think about it, it's kind of like a trampoline. If have no support, that stencil can sag in the middle and it's not going to fill those apertures up. So it's very important to have board support. Make sure that you test that. Make sure there's not a gap between the stencil. Make sure the board is basically sealing against the stencil, and you'll achieve a lot better results if you have a good supported board versus a board that has no support or doesn't have support in certain areas. But like I said, I always like fixtures instead of pin supports that go underneath there. Fixtures designed for that board, and you're going to get support across the board. And can a bent squeegee blade affect printing? Absolutely, no different than the importance of board support. If you have a bent squeegee, you may not be pressing the blade down on the stencil like you need to, and it's going to cause printing issues in the end. So, with that, stay tuned in the coming weeks for part 3 and 4. And with that, I'll turn it over to William. Thank you.
Thanks, Jody. Thank you guys for tuning into this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.